Okay, so now today I'm still going in detail about the reactions, and this is the second type of redox reaction we talked about in an earlier video called decomposition, where we have more complex going to simpler. So it's one more complex substance going to simpler substances. So I'm going to do water. We're going to decompose that with electricity. And when we decompose water, it goes into its elements, simpler things. And remember that elementally, hydrogen and oxygen are diatomic because the 7 diatomic elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Horses need oats for clear brown eyes. So we ask ourselves, is it balanced? No, it's not. We have a 2 here, we need 2 oxygen, so we put a 2 there. Now we have 4 hydrogen, we put a 2 there. Let's look at the oxidation numbers. Here, oxygen -2, hydrogen's a +1. This is 0 and 0 because they're elemental. Hydrogen gets reduced. In this case, goes from +1 down to 0, and oxygen gets oxidized. It goes from -2 up to 0. And then there's a special kind of decomposition that does not involve any redox. All the oxidation numbers stay the same, and that is when we decompose a metal hydrogen carbonate. And I'll give you a for example in a moment. When we decompose a metal hydrogen carbonate, it goes to the metal carbonate, CO2, and water. Okay, so my example, I'm looking at my notes. Okay, we have sodium, hydrogen carbonate, sodium bicarbonate, which is the stuff I used with the vinegar. It decomposes into sodium carbonate, steam, and CO2. And we just need to balance it. We just need a 2 here, and that takes care of balancing. This one has no redox. Alrighty, I did single displacement in the earlier video, so I am going to go on to net ionic reactions, and I'm going to end this one right now.